In problem 10, we're given a graph, and this particular graph represents the relationship between the time in PM versus the distance traveled. So part A, identify the y-intercept and explain its meaning in this context. So the y-intercept, or the point where the graph crosses the y-axis, well, this is the point 0, 0. So the y-intercept is 0. And this should make sense. So the x-axis is time, the y-axis is distance traveled. So if no time has passed, well, then you've covered 0 distance. So that represents the train is still at the station. So we could say what that means, well, the train hasn't left yet. In part B, find the rate of change of the distance with respect to time in miles per hour. So distance is on the y-axis, time is on the x-axis. The rate of change means the slope. So in the context of a word problem, the slope will usually be referred to as the rate of change. So those two terms are interchangeable. Rate of change is slope. So the rate of change, or the slope, is difference in the y-coordinates divided by difference in the x-coordinates. So we're given 2 points on the graph labeled up here. The first one is the point 2, 100, and the second point is 4, 200. So we'll calculate the slope using those 2 points. So the difference in the y values, 200 minus 100, divided by the difference in the x values, 4 minus 2. So on top we've got 100, on the bottom we've got 2, and 100 over 2 is 50. So the rate of change is 50. Part C, explain the meaning of the rate of change in the context of the problem. So our rate of change is 50. Now, any whole number we could express as a fraction. So 50 is the same as saying 50 over 1. Now what are the units? 50 what and 1 what? So the numerator is distance traveled, so that's 50 miles. And the denominator is hours, so that's 1 hour, or hours after noon. So 50 miles per every 1 hour. And we could say the train is traveling at 50 miles per hour. So in the context of this problem, the rate of change being 50 means that the train is traveling at 50 miles per hour.